Now let's talk about lenses. Refraction, as light goes through some things, for example, glass, water, eyeballs, air, it changes its direction. The light slowing factor is called the index of refraction. So glass has n about 1.5, water has n about 1.3, air has a refractive index of about 1. Refraction at a plane surface is basically light bending at the interface between two refractive indices like this, for example, between air and glass. Now, what are lenses? There are two basic types of lenses. One is called a convex lens and the other one is called a concave lens. Convex lenses are thicker in the center than at their edges. Light coming straight in converge to a focal point for a convex lens. For a concave lens, they are thicker at the edges and thinner at the center, and their light ray diverges away. So they're opposite to those of the mirrors. In this case, the convex lens will converge and they will be positive. Concave will diverge and they will be negative focal lengths. Thin lenses are those lenses whose thickness is very small compared to the radius of the curvature. They can be converging or diverging. Thin lens equation, for nearly all lenses we have two refracting surfaces. Thin lenses are those in which the thickness of the lens is small compared with the object distance and the image distance, so we can pretty much ignore the two reacting surfaces. So in this case we are going to use the mirror equation, but in this case it's going to be called the thin lens equation. It is 1 over O plus 1 over I equals 1 over F. The lateral magnification also is given by I over O. Focal length of a converging lens. So converging lens converge incoming rays to a point. The point at which they converge is called the focal length. Focal length of a diverging lens is a diverging lens will take the rays away from the lens, and so it will have a virtual focal length. The focal length will be behind in the same side as where the object is being formed. So now, what about ray tracing for these kinds of lenses? Well, we're going to use exactly the same terms, parallel, chief, focal ray, right? So for a positive lens, the parallel will be parallel to the surface, pass through to the secondary focal length. Chief ray, again, same thing, goes through the center, reflects back. Focal ray passes through the primary focus, hits the lens, and then becomes parallel. The concave lens, the parallel ray, again, begins parallel to the surface, diverges outwards, and then you have a virtual focal point that it appears to come from. The chief ray does exactly the same thing, goes through straight, and then the focal ray will actually it will come and hit the focus and then become parallel to the ray. First, let me talk about how these lenses behave in certain situations. So first off, we are going to talk about our positive lens. So our positive lens is our convex lens. And what that does is all the rays that are coming in, it basically converges them to a particular point. So I'm doing a terrible job, but this is what it does. My negative lens, what it does is it's going to look like this. And what it's going to do is all the rays that are coming in parallel will actually diverge away, except for the middle one. So that it appears that all of these rays were coming in from a focal point here. So the focal point for a positive lens will be actually here, and the focal point for a negative lens will be here. Now, how does these translate to what we were talking about before? So I'm going to still use the same three colors, parallel, focal, and chief, okay? Let's talk about the positive one first. So the way you make the positive lens on your piece of paper is this way. And you leave it empty. Do you remember when we were talking about mirrors? I actually filled it in. In this case, I am not going to fill it in because it's a lens. But everything else remains the same. So I have my optical axis in the middle, I have my focal lengths on both sides, and I have my object. So let's start with a parallel ray first. So parallel was, remember, with black, comes, hits, goes through the focus. Next one was my chief. Now again, remember it is a refracting surface now, so it's going to come in and keep going. Okay, it's not going to be reflected back. The third one is focal. Now this is slightly different from the way we were doing the mirrors. For the mirrors, we were using the same focal point for both scenarios, but this one is a lens. It has two sides, right? Because it has two sides, we're going to use both focal points. So the focal ray will come through the focal, hit the lens, become straight, and go here. Where these three meet is where the image is going to be formed. About here. Let that sink in, and then we'll do the next one. So for the negative lens, the way I'm going to draw the lens is this way, right? Empty, 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 empty. This shows its negative lens, and also it will have an optical axis. And I'm going to assume that my focal points are here. Now again, it's a lens, right? So we're going to have to use both focal points. So I'm going to just randomly put a object here. Now how does this work? So the first one is going to be parallel. Okay? This is a diverging lens. So it is going to diverge outwards, but by how much? By this much. Chief, nothing is going to happen. It's still going to go through the center and go on. And the focal length, I've used this focal point. I'm going to now use this one, right? So I'm going to draw a ray that goes here, goes through my focal point, and then goes straight out. Okay, again, the negative lens is a problem because it doesn't really, they don't match up anywhere, right? So I'm going to start now extending things to make sure somewhere it should match up. And I'm going to extend this one backwards. Oh, there we go. Here's where they meet up. And here's where the image is. Sort of, right? Of course, they're not drawn to scale, but this is going to be a real image. It's inverted, it's real. You can put it on a screen. This one is going to be a virtual image. It's upright and it's virtual. Okay? So this is how you deal with positive and negative lenses. You may have to practice this a little bit.